Hello, everyone. Today we are going to begin our factoring section of Unit 7. So today we are going to start factoring using the distributive property. I will sometimes refer to this as your GCF because when we use the distributive property to factor, the distributive property has been used in the past to multiply a polynomial by a monomial. It can be used to express a polynomial in factored form. Compare the two columns. So when we're multiplying, we take the 3 and we distribute it to both terms, and we get 3a plus 3b. When we're factoring, we're looking at the fact that 3a plus 3b have a common factor of 3. So we factor out the 3 and make it 3 times a plus b. So again, when we distribute, we multiply everything inside by what's on the outside. When we're factoring, we're looking for the common factor that's in both. In this case, it's x, and then it becomes x times y minus z. And then that can become more complicated, where we're looking for a common factor that's a number as well as a variable. So when we look at our last example, we have 12 and 6. So the common factor of 12 and 6 is 6. And then variables, both terms have a y. So it would become 6y times 2x plus 1. So, example 1, use the distributive property to factor 12mp plus 80m squared. So first we're going to look for the GCF, which stands for greatest common factor. So the greatest common factor of 12 and 80 is we're looking for the largest number that goes into 12 and 80. Which the greatest common factor of 12 and 80 is 4. And then we're looking at our variables. So when we're looking at our variables, we want the highest exponent of each variable that's in both. So since p is only in 12mp, p cannot be qualified. And then m, for 12mp, we have an m. So that's the highest one that's in both. So now our GCF is 4m. So the GCF goes on the outside of our parentheses. And then what's inside is what we would need to multiply by. So 4m times what gives me 12mp? So that would be 3p plus 4m times what gives me 80m squared, which is 20m. And that's factoring. Now, we can also factor by grouping. So if we have 4 terms, sometimes all 4 do not have a common factor. But if we group them in 2 and 2, as I've done in the first step there, sometimes that will have a common factor. So when I group the first 2, they have a common factor of 3a. So that becomes 3a times 2x plus y, plus then the second group have a common factor of b. So that's b times 2x plus y. You will notice what happens quite frequently is 2x plus y is a factor of both terms. So I can write that as 3a plus b times 2x plus y. So what I did is I factored out the common factor of the 2x plus y. Now to check that we did that correctly, we can use FOIL or double distribute. So I'm going to multiply that. So 3a times 2x is 6ax. 3a times y is 3ay. Plus b times 2x is 2bx. And b times y is plus by. And you'll notice I have the exact same thing. So this is the factored form of that expression. Let's do a couple more examples. So 24x plus 48y. I'm looking for the greatest common factor. They have different variables, so I'm really just focusing on number. So 24 and 48 have a common factor of 24. So that's 24 parentheses x plus 2y because 24 times x gives me 24x, and 24 times 2y gives me 48y. Number 2, here I have a lot, so notice my middle term only has a factor of 1, coefficient of 1, therefore my number is only 1. I'm looking for the largest exponent of each variable that's in both. This last term does not have an m, therefore I cannot use m. They do, however, all have a p. So my greatest common factor is p, so it's p times 30mp, because p times 30mp would give me 30mp squared, plus m squared minus 6. So I want you to pause, and I want you to do 3 through 9. And come back and check. Number 3, my GCF is q. So it becomes q times q cubed minus 18q squared plus 22. Number 4, I'm looking for a number that goes into 14, 42, and 49. So that's 7. And I want the highest exponent of t that's in everything. So that would be t cubed. So 7t cubed times 2 gives me 14t cubed minus 7 times 6 gives me 42. And then t squared times t cubed gives me t to the 5th minus 7t. Number 5, I have a GCF of 11, goes into 55, 11, and 44. And my exponent is p squared. So 11p squared times 5 give me 55p squared minus p squared, because 11p squared times p squared gives me 11p to the 4th, plus 4p cubed. Number 6, my GCF is y. So that's 14y squared minus 28y plus 1. I must have that 1, because without that 1, when I distribute, I do not get the y. Here for 7, 8, and 9, I'm doing my factoring by grouping. So I'm going to group the first two and the last two. Notice I leave the plus sign in the middle. The GCF between x squared and 2x is x, so that's x plus 2, plus the GCF between x and 2 is 1, so that's 1 parentheses x plus 2. My x plus 2 is now in both, so that's x plus 2, parentheses x plus 1. Number 8, group the first two, group the last two. GCF between 6y squared minus 4y is 2y. So that gives me 3y minus 2, plus GCF between 3y and negative 2 is 1. So that's 3y minus 2. I have 3y minus 2 in both. So that's 2y plus 1 times 3y minus 2. Last one, I'm going to group the first two and the last two. So the GCF between 4m squared and 4mp is 4m. That gives me m plus p, plus GCF between 3mp and 3p squared is 3p. So that gives me m plus p. I have m plus p in both, so that's 4m plus 3p times m plus p. That is the end of our video today. We will do the last 3 problems to start class off tomorrow. If you have any questions, please ask.